Okay. Uh, let's look at cubic functions. So, lesson 14, let's look into cubic functions. Right, let us recall that in the past we learned about a parabolic function. So, a parabolic function is a function of this equation there. Right, so can you see that ax squared plus bx plus c, that is a parabolic function. So a cubic function has the form of, as you can see here. So, okay, let me do that. Right, so as you can see here, that is a cubic function. Can you see? So the highest degree of a cubic function is actually 3, right? And then d is the y-intercept. So d is actually the y-intercept, right? So this is the y value which the graph cuts through, right? And then a and b. Let's look at these two guys. So a and b are actually stationary points, or what we call turning points, but I would prefer we call them turning points, right? So these are turning points actually, A and B, right? And then A is called the local or relative maximum turning point, and then B is called the maximum, or sorry, is called the local or relative minimum point. Now, while we are still on that, let's go back to a parabola, right? Remember, for a parabola, C was actually the y-intercept, or is actually the y-intercept, right? And then now, if you draw a parabolic function, right? Suppose if we draw a parabolic function of this nature here, this actually becomes the minimum y value. Okay, so the y value of the turning point is actually the minimum y value. Yeah, is the minimum y value, the y intercept of the turning point. And now this yes, actually I'm right. The minimum y value, right? So that means the turning point here will be the minimum turning point when a is actually positive, when the graph is facing up. But now, when the graph is facing down like this, right, and then our TP here, the YTP here is what we call the maximum y value. Can you see that? Right. So when the graph is facing down, for the maximum value, maximum turning point. When the graph is facing up, for the minimum turning point. Now, you know that the highest degree of a parabolic function is 2, right? It's 2. And then it has got one turning point, right? So the number of turning points is actually the highest degree minus 1. So the highest degree here is 2, then 2 minus 1 is 1. That means we've got one turning point. Now let's go back to a cubic function. The highest degree of a cubic function is 3, right? So number of turning points, remember, is the highest degree minus 1. So what is 3 minus 1 is 2. That is why for a cubic function, we've got 2 turning points, right? So number of turning points is equals to the highest degree minus 1. Right. Now, for a parabolic function, it's either we have got a maximum turning point or a minimum turning point. That's it. However, for a cubic function, we have both. We have the maximum turning point and the minimum turning point on the same graph, right? So they are saying before sketching the cubic function, it is important to understand the shape and concavity of the cubic function. Right. We'll talk about that. Right. Now, let's go to the next slide. So the next slide here, you've got these two graphs here. So when A is positive, let's explain that. When A is positive, the first turning point will be the maximum, and the second turning point will be the minimum. So when A is positive, the graph will take this shape. Right? When A is positive. So we start with the maximum turning point, then we come to the minimum turning point. So that means the maximum first, the minimum after. So when A is negative now, the graph will be this way, as you can see, right? Meaning the first turning point will be the minimum, and then the second turning point will be the maximum turning point. Can you see there? Now, let's talk about this point here, right? So this point here, which I'm highlighting on the first graph, right? So we are this side, right? This point actually changes the concavity of the graph, right? Now let's just draw a line here, right? And that's so good. All right, so let's just draw a line here. You can see from negative infinity to this line here, the graph is concave down. You can see it's concave down. But from this point going to the right, the graph is concave up. So this line here tells about the concavity of the graph, right? Which is the point of inflection. But we'll go deeper into that as time goes by. Right, as you can see here, right? And then concave up, concave down. Can you see that? So once you understand that, it's easy. So when A is positive, the graph starts with concave down and comes with and then concave up follows after. When A is negative, the graph starts with concave up and then concave down after. Right. So now let's discuss this. So this is actually important, the cubic graph. Right. So a cubic graph has 3 x-intercepts because of the highest degree here. Remember, the highest degree is 3, therefore 3 x-intercepts. Now let's go back to parabola. Parabola has got the highest degree of 2. That is why it has 2 x-intercepts. Right? So the number of the highest degree determines the x-intercepts of the graph. Right? So here for a parabola, the highest degree is 2, and then that's why we've got 2 x-intercepts. Then for a cubic graph, the highest degree is 3, hence we've got 3 x-intercepts. Right, so yeah, so the point where the concavity of the graph changes is what we call the point of inflection. As you can see here, it's indicated. And then now the turning points there, the turning points actually are what we call the stationary points, right? The turning points are what we call the stationary points, right? So now before I can actually go deeper into this, I'm going to explain something on lesson 15, I think, and then we'll take it from there. Right, so now I was just explaining the cubic graph, how it's drawn, the shape and whatnot and whatnot. Now let's go to the next lesson and explore more.